I think I'll actually get started. And as I run through my hopefully not long-winded intro, but my intro, we'll have the rest of our registrants continue to trickle in. So first off, I just want to start off with the important act of reconciliation and gratitude, to take a moment to acknowledge that I'm joining you today from Treaty 6 territory, traditional homeland of Métis and Inuit, and ancestral territory of many First Nations, including the Cree, Dene, Blackfoot, Saulteaux, and Nakota Sioux. We acknowledge many First Nations, Métis, and Inuit who have nurtured and cared for these lands since time immemorial. So good afternoon, everyone. My name is Pamela Gertzen, and I'm the Executive Director of the Smart, Sustainable, Resilient Infrastructure Association, also known as SSRIA. So we are a not-for-profit organization that is taking a collaborative, industry-led approach to reducing carbon in the built environment by accelerating adoption of innovative, low-carbon solutions. So as part of that, we're actually currently funding 16 demonstration projects across Alberta and actively sharing the results of those projects through webinars like this one today. I'm going to apologize because I have a very dry throat, so I'm just going to take a quick sip of my tea. Sorry about that. Anyway, so we share these results from these projects through webinars like today's, but we also have a Building Innovation Reference Center. And so this is an online searchable database of information that's related to each one of the projects. And it's being populated as the projects are being implemented. We actually have our first project that just closed out. So final data from one project, which is really exciting to see. And then many of our other projects are just moving into that measurement and verification stage. So a lot of that data is soon to come, and you'll be seeing a lot being populated within that tool. And as part of that, we are aiming for a really good mix of both technical data and details for those who really want to dig in, and then more high-level information if you're just looking for a general understanding. We also have recently announced the dates for our annual conference, the Alberta Energy Efficiency and Innovation Summit, which is taking place June 20th and 21st here in Edmonton. So that's very exciting. We have just opened early bird registration, which is 20% off the regular rate. And if you're a SSRIA member, it will be 30% off. So just another great reason to register early. Give me 1 second. Boy, it's going to be a struggle for me to get through this one today. If you do have any further questions, you can certainly reach out to me in the chat or at my email address, which is pam@sria.ca. For today, we have William Yen, who is the owner of BM Homes. William has a Master of Science in Construction Engineering and Management, and is currently pursuing his PhD. So add that to his 20 years of experience in residential, commercial, and industrial construction, and I think we'll have quite a great learning from an expert in the industry here today. William will be sharing some information about the multi-use building micro-CHP project, a building that he actually re-engineered after William learned about micro-CHP and thought that the use case for this building would be a really great match. So with that, I will pass it over to William to run through the presentation, and then of course we'll have a Q&A at the end as well. So thank you.
Hello, can you hear me?
Yep, you're coming through great, William. Thank you.
Okay, yeah. Hi, everybody. And my name is William. And since working in the building industry more than 20 years now. And today's topic is the mCHP, the macro combined heating and power for the mixed use building. And first, I thanks Sarah gave me a point, and Kate and Laura gave me this chance to share this experience. And we are quite pleased this project almost done. If the next month will be better, but that's what we got so far. Okay, and first we have an introduction. Then will be the history of the mCHP. Then we talk about a little bit about the design, then the construction, and the future work, and the final wrap up will be the questions. Here is the building, which is located in downtown. As you can see, the After Tower and Stantec Tower is in the background. Actually, it's located in the Chinatown, and it's a 3-story steel concrete building. Each floor has about 2,000 square feet. The main floor is a restaurant, and the second and the third floor will be 2 residents, which we call it mixed building because the main floor is commercial and the second and third floor is residential. I will talk about a little bit this disadvantage and advantage for this kind of mixed building. And the good part for the mixed building is actually the restaurant need some consistent and continuous hot water, which is a pretty good setup for the mCHP, because when the CHP generates the power, they will co-generate the hot water as well. So that can be supplied to the restaurant. Usually we don't have this kind of setup in the residential for the continuous hot water use. You know, like the shower, you just take it 10 minutes, 20 minutes more maximum. But as a restaurant, this kind of business, we can have take the advantage for the hot water use continuously. And the building is built almost done, and the later on we can see still some interior finish work, but all the equipment is set up already. Okay, that's the system we are talking about today. As you can see, the bottom is the big box is to 1.5 kilowatt mCHP, and it will generate the electricity with the hot water. And above that 2 box, you can see 2 electrical box there. And at the back, if you see some the round one, it is the hot water tank. It's like 6 feet, no, 5 feet and 5.5 feet. On the right, you can see 2 tankless hot water heater. That's the backup system, because as we thinking, if this system got maintenance or got down, especially the very cold weather, like the minus 20, minus 30 in the winter, and those 2 tankless water heater will kick in as well, because the CHP itself cannot handle that much water. That's the brief introduction, and I'm gonna talk to a little bit the history about the project. In 2019, and I go that Eco Solar tour. Some of you maybe just go there as well, some by any chance. And I saw this office building in the Bonnie Doon that by Effect Homes, and they do the whole system off grid. Although they are in the near the downtown area, but they just want to try the off-grid. Actually, they used solar PV for the electricity in the summer. And at the bottom right, you can see the same kind of CHP system. And they will use that one for the winter. Because as you know, in the summer, there's not too much heat needed. And in the winter, not too much sun. And they kind of like off-grid system while the solar will working on the summer. And those two CHP will be generate electricity in the winter. As I said, this system is completely off-grid. When I saw that one, is quite amazed, actually, yeah. Because my background is about working in the oil industry. And before I came to Canada 20 years ago, we did a huge, big CHP program. And that one almost supply 20,000 people for the whole hot water. That's the first time I saw those kind of small macro CHP, and which is quite convenient for the single building. And I just want to trace back and see more. And next year, on the 2020, I attended the Builder EX. Some of you might be go there as well. By the way, those kind of event or like the tour is really open your eyes. I'm really enjoy those kind of webinar or seminar or the conference or the trade show. Those kind of it's really give you some solution. Even you don't have kind of realize some gaps there, and they realize that one, and they try to fill that gaps. Anyway, for the Builder EX, Edgar and Zeta do a presentation, and it's one fact is very surprised me. Like you can see, the electricity in Alberta is quite green gas intensity. The green gas for the Alberta's electricity is 0.57 tons, and which is much higher than the gas. The gas is only on the bottom right. You can see it's only 0.18, which is 1/3 of the electricity. That's really changed my opinion about the gas. It generate less greenhouse gas. And the other thing is the electricity is really expensive, especially the transmission. As the left, you can see it's roughly $23 per month. And the price is 0.15 per kilowatt. Compared to the gas, it's only 2 cents per kilowatt. Those things just let me think about the gas is not that green. It's even greener than the electricity. Of course, in Alberta, we just eliminate all the coal mine recently. This state is by 2019. Now the situation will be better, but still the gas will with us quite a while, I think. Yeah. Another thing is, as you know, Alberta is the oil gas country, and it's hard to us to just eliminate all the gas usage and all the infrastructure there. So that make me think do something about use the gas more greener, and the CHP I think is one of the solution. Okay, during that seminar and the expert gas introduced that small residential house in the new neighborhood and Edmonton. And the next day I went to the seminar and I go there. and I saw this box because it's sitting outside, and it's quite small, and I use the meters to test it. As you can see, it's only 46 dB, and it's pretty quiet. So I think we can put that one in the basement. That was exactly we did it in our own project. And at the bottom, you can see this one is not like Effect Home's complete off-grid. They still have the gas and they still have the power meter. This one is just like a run a test for the residential area. Now we have the usage for the office, which is the commercial, and we have the residential. What I'm thinking is to get something like the mixed use that come to our project. This is the main floor of our project, that Chinatown's 3-story. The main floor will be a restaurant. On the upper, you can see the hood is there. It's pretty big. One is 16 feet, one is 8 feet. As I said, the project is not finished yet, but it's gonna be pretty soon. We're gonna put all the equipment under that hood, which is a lot of hot water use year round. And on the bottom, that one will be the restaurant, the public area. And of course, it's still in the construction, and those seats is not there yet. But let's see if I can share something later by any chance to give you a finished picture. But this is pretty much the picture right now, and we do have the usage for those hot water, which is generated by the CHP. This is the upstairs. Upstairs will be 2 residential units, and as you can see, the floor is not there, but the interior pretty much done, and we already drywall it and mud it and put all the interior wall, those kind of thing there. And the main part for the residential is the next one. Let's talk about the design. On the left, you can see 2 CHP, which is 1.5 kilowatt. The blue line you can see is the cold water coming in. First, if you see on the top DCW, that's the domestic cold water coming in from the outside. Then the blue line, if you follow the blue line, it goes to the hot water tank. That 2 hot water tank is just act as a buffer tank. The tank itself is an electrical tank, but we don't use that function. It just used as a buffer tank, those 2 tanks.
And he spends a lot of time out.
And from the tank, it goes to those 2 CHP. Those 2 CHP will generate electricity and hot water. And if you see the black line come out of the CHP, will be the hot water. Hot water goes to the fan coil, and also supply the residential bathroom for the shower or for those kitchen usage. On the right is the 2 Nevin instant water heater. As I mentioned before, those 2 is for the backup system. Like in the really cold winter, we cannot just use those 2 CHP to generate enough for heat water to heat the residential part. So we need some kind of system to deal with those cold days. That's the one reason those two tanklets never be there. The other reason is if anything need maintenance for the CHP, those two never also can kick it in to supply the hot water to the restaurant and supply the water heating for the residential, which is upstairs. That's the basic design idea. If you can see the upper, it's also how the return hot water from those two residential units fan coil. It's gonna go back to the tank, then reheated by those two CHP as well. Actually, one of the things I want to share is not too many people knows how to do those kind of CHP system. This actually we got the contractor all the way from Lloydminster, because as I mentioned before, the CHP is originally from the big scale industry use. Those guys is really familiar with this kind of system, and but for the gas oil industry, and they use in the remote area. And actually they build those system in their shop in Lloydminster. And they assemble everything. If you can see all the pipes is laid out already, then they disassemble those and ship it to Edmonton and install those on site. Those three pictures is from their shop in Lloydminster. They literally assemble everything and just detach it and reassemble it in Edmonton. And here is the final product. Pretty much we got the things all wired up, and all the HVAC system, electrical system is wired as well. And we just need the final occupancy, then we can just test the whole system. We can have a lot of the monitor. If you see this one on the bottom right, and those are the gas meters. Each Nevin and each CHP will have their own gas meter to monitor it. And also each CHP has their own water meter to monitor it. And as well as those electrical system will be monitored the whole thing about half a year, and see how it goes and give some feedback for the future usage. This is the detail for the manifold area, which is on the left. You can see it's about those two tanks. The A is the domestic cold water coming in, and B is the hot water out, which is supplied to the restaurant. As I mentioned before, restaurant has a consistent water usage, so that line is specific for them. The C is for the return from the fan coil. After the fan coil upstairs, the residential unit, and it will be cold, and it will back to the tank, then reheated by the CHP. On the further right will be D and E. It's for the two fan coil on the residential area. After those two red is the mixing wall, control the temperature, then goes out to the upstairs fan coil to heat the upstairs. This is the picture for the upstairs residential. You can see two fan coil, which is receive the hot water from the CHP, and goes out by the forced air to heat the residential unit. This is the top view on the rooftop. And we have big gas meter for the rooftop unit and make up air as well to monitor the gas usage for them. And we have a 5-ton rooftop unit and 7.5-ton make up air. And we have a fan here as well. This is the top view on the roof. And the electricity will be coming from the CHP and goes to these meters here and monitor it. The last part will be some future usage. As I mentioned before, makes the building really take advantage for the CHP, which is generates the hot water and the electricity. What we can think is some business like this one. This one will be a restaurant as well. And I'm trying to persuade the owner to do the other CHP system as well. Let's see it goes through or not. Basically, the return is a bit longer, like the 12 years to 13 years. They're still thinking about that. But right now, we can see more and more mixed use building in the infill area and the new development area like here. And I think in some usage like the spa, the hair salon, the restaurant, and those kind of business need hot water use can more fit for the CHP. The other thing is even it's office area or some commercial bay, it still has some advantage for the CHP system. As you know, in the daytime, the residential part usually don't use the hot water, but the commercial part will be have some hot water use, and we can just fill that gap because the residential unit and the commercial unit didn't occupy the same time. So that's one of the future use. The other thing is we still thinking about go to the rural area, which is off grid. I do have one chance. There's in the Sturgeon County, they do have the gas pipeline there, but they don't have any electricity grid there. So that kind of area is fit for the CHP as well, because you know, as long as the gas line there, we can generate the electricity instead of use those kind of diesel or gas or oil propane generator. We can use the CHP, which is less green gas generation, emission, and more efficient. And the other use I think is, you know, the for Saskatchewan just have a big hydrogen project like this. If I remember right, it's 3 billion project by the Dow Chemical. Those kind of hydrogen is a potential use by the CHP as well. Those the future use target which we can think and will be continue working on those. That will be my presentation. Thanks. Any question? Yeah.
Thank you very much, William. So of course, anyone can put questions in the chat, or if you want, you can certainly unmute yourself and go ahead and ask your question. Maybe just to avoid, you know, people talking over each other. Just lift your hand, and then I can call you out when you're up to ask your question. So while you're all preparing your questions, I had just had a few that I wanted to chat with William about. And I think it was really great to see how, and I'm really glad you shared the history of how you decided to try to apply this technology in this building. And the fact that it kind of comes back to the EcoSolar Home Tour. So I hope somebody from the EcoSolar Home Tour is listening and learns that, because that's to me a huge success. And one of the reasons that we do this as well is to share this information so that people can take away and work on their own projects. So that was really great. How do you think for you, or what were some of your biggest challenges that you had encountered through this project? I know you talked a little bit about the lack of supply. But is there anything else that was a major challenge as you went through this process?
Yeah, Paul. As I said, this kind of project, even somebody did those kind of thing before, but when we change something, it's always something come up. Like the first is we want to try to use the other kind of system. As you know, the Yamaha's 4 kilowatt CHP, but that one is the supply chain has problem, and only one in Canada, and it's 8 kilowatt, I think. Yeah, and we really face on the need to change the back to the 1.5 kilowatt CHP. That's one issue. The other one is it's really like it's still in the frontier area. It's really the substrate need to be trained for those kind of installation. As I mentioned, we need to go really far north to the Lloydminster to find the subcontractor. That is one of my hope. Just through those projects, we got not just the consultant get trained, also the subcontractor get trained to use those new technology. The last one I can think is like anybody else facing is the pandemic, and like my rooftop unit is really sitting there for waiting for the whole thing 5 months, literally 5 months about the supply chain. It's really frustrated, but we finally go through those.
Yeah, thanks for sharing that. There has definitely been, we've been seeing through all our projects the delays and the supply issues and the labor issues. So it definitely comes to really the spotlight when we're working on more even of the innovative projects, and it's more specifically highlighted. For the users of the space, is there going to be kind of like a learning curve, or are they going to need to like not training's not the right word, but be brought up to speed a little bit on how to operate and maintain? And is there a different usage case a little bit with this type of system?
The answer is yes and no. It's do need train the owner or the final product user a little bit. But the good thing for the CHP is they don't need too many maintenance. It's gonna run like the first 15 years will be not change any part of that. And we do have as I mentioned, we have a monitoring system there. And if you can remember, there's 2 gauge for the just about the mixing wall. Those 2 need to be changed, just like your regular hot water tank. If the final product user, like the resident, want to their showers water a little bit hot, they can change those 2 temporary gauge to affect that one. Otherwise, it's gonna be pretty straightforward. And we have some development about the restaurant hot water use, and we gonna set up an initial one. But we don't want any change of that one. Even the change will be affect the whole system. As I mentioned before, the electricity generation, it really depends on the hot water usage. And the good thing for the restaurant is they are quite stable for the hot water usage, no matter summer or winter. It's not like the fan coil on the residential part. You don't use those fan coil in the summer quite often. But yes, and we need some training, but it's minimal. If you can use the hot water tank, change the temperature, you can use this one too.
Okay, great. Chris, you have a question.
Yeah, hey, William. You might have answered this already, but I was just wondering how you decided on two 1.5 kilowatt sized units. And I'm guessing it was based on your hot water usage, not on your electricity usage.
Exactly. The electricity only can generate about 70 to 8% of the total building's electricity use. We don't want to go too far because first is the supply issue. Originally, those will be used 4 kilowatt, bigger CHP, but that one is not available. The second one, even we have that one, we don't have that much hot water usage. So I think 1.5 each is good enough for this project.
Okay. And you said you considered Yanmar micro CHPs as well, or?
Yes. We originally we think that one, but the first one is the supply chain. There's only one sitting there I think in the Ontario at that time, and it's 8 kilowatt. It's overkill, and the price as well. Yeah.
Okay, thanks.
Yeah, this project, unfortunately, like many of our projects, were through like I said, a fairly turbulent time, and we were working with William to figure out how we could this project could move forward with the supply issues. I think at one point, William, we were talking, and there was 8 months to a year wait on some of the CHP units. So it was definitely an added challenge on this project for sure. And I see a question in here from Jesse, who was wondering about the anticipated reduction in GHG emissions, and if that's been calculated at this point in time, compared to like a traditional building design.
Yes, we already calculate one. The greenhouse gas will be, by calculation, will be 26% reduction for the whole project. Thanks for mentioning that, Jesse. And we use the RET screen, which is developed by the Natural Resource of Canada. If everybody interested, it's really good software, and it's free of license if you use the basic model. And you can calculate the greenhouse gas emission, and you can calculate the efficiency and the productivity by all kinds of new things. Like I use that one for the wind turbine, for this CHP, and you can use it for the geothermal, and of course the solar PV, those kind of things. It's a really good software that I recommend it. Yeah.
Thanks for that. And you kind of touched on this a little bit at the end of your presentation in some of the other projects that you're looking at. But overall, how do you find that going through this project and working with the micro CHP and just the different types of building systems, how has this impacted in you, and how will it change your future projects?
Yeah, like I said, the good thing is sometimes we find the gap and we feel it. Sometimes we find the technology and for the application of those gaps. I think I'm in the second situation right now, and right now we just go through the whole circle of the mCHP, and as I mentioned, we find kind of what kind of application can this mCHP can do. Right now, like I said, the mixed use definitely is one of the direction, because it's more efficient than the single use for the office building or for the residential, the sole residential apartment, and we do have more and more mixed use building there, and we also find the gap for the remote space, like the country over the country and off grid. But the problem for that is we didn't touch too much about the market. If the market is there, it's a really good chance that CHP will success there. Like 2 months ago, I even asked the Chat GPT what kind of percentage for the Alberta rural area has the gas line and don't have the electricity, but Chat GPT didn't give me anything. Yeah, and I think if we really want to explore that option, we need to go the county by county, talk to those guys. You don't have data, no data, and you don't have answer. And if we have chance, we want to explore that area as well.
Great. Thanks so much. That was really great. Thanks for sharing your experience. And yeah, like you mentioned, there'll be more information, more pictures, more data to come as the building is completed and the restaurant starts operating and those units are occupied. So that information will be shared in the future through our Building Innovation Reference Center, which I believe there's a link in the chat box if you guys want to check that out now. And a great way to kind of stay engaged and informed about the information that we're putting out is sign up for a newsletter. So you can do that on our website. If you just scroll all the way to the bottom of the website, you can sign up for the newsletter if you're not already getting that. And that's a great way for us to keep communicating and share that info. So thanks again, William, for sharing some details about your project. And we look forward to getting the kind of final results in the next, I would say, I guess 6 months or so is what we're anticipating at this point. So, and thanks to all those who joined us today. Recording will be sent out to all those who are registered over the next few days. So thanks again. Have a great afternoon, everyone.
Thanks.